So in this tutorial, we'll be talking about sets in Python. So a set is actually a collection of data type. It is actually unordered and it is mutable. So yeah, you can actually modify a set, and it does not allow duplicate elements. That is the most important thing. So without further ado, let's get started into the tutorial. So you can declare a set by simply calling it my set, or yeah, whatever you want to call it. I'll call it my set, and curly braces, and yeah, just like dictionaries, but you don't have a key and a value here. It is simply numbers. So I told you that it won't accept duplicate elements. Let's print out this set and find out what I mean. Or if I just run this program, okay, let's just run this program again, and you can see that those duplicate elements were not printed. So if I try 2, and yeah, and if I run this program again, duplicates elements are not being printed. So that is the most important thing about sets. So it's a nice way to avoid these duplicates. Now you can also declare a set by saying maybe my set 1, and let's say set is actually a keyword. You can declare, or you can actually declare a list inside it, and it will be converted into a set. So yeah, I'll do the same thing here. 1 2 3 4 5, and if I print out my set1, if I run this program, you can see that this has been printed, and this is actually a set now. We have declared list inside a set keyword, but it still has printed out as a set. So let's just remove this. So we have our original set now. So let's check some, or let's do some operations, or some things that we can do with sets. So we can add items to a set by dot add method. So my set dot add, and you can maybe add 10, and if I run the program, you can see that an item has been added to the set. And you can remove an item by remove, and you can remove maybe 3, and if I just run this program, you can see that 3 has been removed. I can remove whatever I want. I can remove 1. Okay, so 1 has been removed, and maybe 4. Let's try 4. Yeah, everything will be removed. So in this case 4 has been removed. So yeah, we have other methods for removing, like the clear method. This thing takes no argument. This thing clears the full set, so we'll get an empty set in return now. Okay, so yeah, we have an empty set now, and it's called set. And now we have another method. So we have another method called pop method. So if I say pop, and if I just run this program, you can see that the first element has been removed. So pop actually removes the first element in a set. One thing I just wanted to tell you is that on how to create an empty set. So normally we can just remove all these elements and it will be empty, right? If I run this, you can see we get an empty curly braces, but this is not an empty set here. If I just print the type of this now, if I say print type of my set, if I just run the program, it is actually a dictionary and not a set. To actually declare a empty set, you have to say set of this set of braces, and if I run this program, now it is actually a set. So now we have an empty set. So this is how you can declare an empty set in Python. So let's just get back to where we were. So yeah, so let's declare an empty or a set here. 1 2 3 6 7 8. Yeah, that should be enough. So we can actually iterate over this set using the for loop, just like we do with other things. So I can say for set, okay, set is a keyword, so we cannot use set. So maybe for I in my set, and if I just print I, this I can actually be anything. This is just a variable. You can change it to x maybe if you want, or a or b or whatever you want. So in this case I'll just print x, and if I just run the program, yeah, you can see that each individual element has been printed, and at the end we just got our set. So we can check if an item exists or not in a set using the if statement. So let's say we can check if an item exists in a set or not using the if statement. So if I say if 1 in my set print, we can print yes, it does exist. So yeah, else it should print no. So yeah, if I just run this program, we get yes. Just comment out this set, we don't need it printed again and again. So if I just run this program, we get printed yes because 1 exists in this set. If I just change this to 10 and rerun the program, we get no, which means that number does not exist in that set. So now we are going to talk about union and intersections for sets. So you may have actually heard of this in your mathematics class. So let's actually discuss further. So I have 3 sets here: odds, evens and primes. So yeah, this contains odd numbers, this contains even numbers, and these are all prime numbers. So to find the union, we say u is equal to odds dot union, and inside this we say evens. So yeah, if I just print this, we'll get a combined list of both these things. So that is what union does. So I'll show you, just run the program. Yeah, we get a combined list. So we have 0 1 2 3 up to 11. So yeah, it has all the numbers combined in both these sets. So actually this is actually some mathematics here. So you may have heard of this in your mathematics class, in your sets chapter or sets unit or whatever you want to call it. So now we have, this is union. So what it does is it can actually combine both these lists. So now if I just combine this odds with primes, and I can maybe print it, if I just run the program, you can see that this list and this list has been combined. And as I said before, sets actually remove the duplicates, so no duplicates are allowed here. So this 2 I mean the 7 here is actually not repeated twice. So and the 5 is actually also not repeated twice. Same is the case with 3. So yeah, it is not repeated because it's a set now, and it just adds both these sets. That is what union does. So we have, this is what union does. Now we have intersection. So I'll declare a variable here called I, and I'll say odds dot intersection, and maybe we'll say evens. So let's print I. So yeah, what this thing does is actually it will take this set called odds and this second set called evens, and it will actually print out the common elements or the common numbers inside this thing. So if I just run this program, we get an empty set because this is an evens list or an even set, and this is an odd set, so they won't have anything in common. So let's try the odds with the primes one. So now if I just run the program, we get some common elements because we have 3 5 and 7. This is also present in the odds list, so that's why we get it. So that is actually everything about union and intersection. Okay, so now we are actually going to calculate the difference of the set. So we actually did union, intersection. Now let's calculate the difference between the two sets. So I have two sets here called set A and set B with some numbers inside. So what I can say is I'll just declare a variable here called diff, and I'll say set A dot difference set B. So yeah, what this will do is it will actually return all the elements from the set A that are actually not present in the set B. So in this case it should actually return 4, 5, 6, 7, 8 and 9. So if I just print it, it will be more clear to you. So if I just print diff, if I just run the program, yeah, you can see that 4, 5, 6, 7, 8 has been printed. So yeah, so I'll explain to you once more. So it will actually print all the elements from the first set that are not present in the second set. So I can actually reverse this. I'll say set B here and I'll say set A here. So in this case it will actually print all the elements of set B that are not present in the set A. So in this case it should print 10, 11 and 12. So if I run the program, yeah, that is what you see. We see 10, 11 and 12 because it is only present in set B. So we have been doing a lot of stuffs like union, intersection. So we actually create a new set here. For example, I have diff here. So this is actually a new set. We never actually modify the original set. The original set is still the same. Okay. We have never modified the real set till now. We actually have defined separate sets, or we have never actually modified the real sets. So let's see how we can actually do that. So let's take this, let's comment this thing, both of these out, and okay, so yeah, so now we have two sets called set A and set B. So so we have two sets called set A and set B. So let me actually try to modify this. We can actually modify this by saying set A dot update set B, and if I just print set A now, if I just print set A and if I just run this program, you can see that so we have actually got this set here. So what update method will do is it will actually combine both these sets, and of course it will actually avoid duplicates, and it actually is kind of similar to the union method, but this will actually modify the original list. So we also have an intersection update method. So I can say maybe set A dot intersection update and set B inside. So now if I just comment this out and run the program, you can see that 1, 2, 3 has been printed. Okay, here I have done an intersection update. So set A dot intersection update set B. So what this will do is this will actually get the common elements from both these sets. So in this case it is actually 1, 2, 3. If I just run this program, you can see that these three elements are actually printed. So we also have the difference update. So I'll just comment this out and I'll say set A dot difference difference update for set B. So if I just run this program, so if we just run the program, we get 4, 5, 6, 7 and 8 and 9. So what this difference update method does is it will actually remove the common elements and then it will print the remaining elements. So that is about the difference update method. The next thing we are going to discuss is the symmetric difference update. So I say set A dot symmetric difference update set B, and if I just print this out, you can see that 4, 5, 6, So it actually avoids all the common elements from both the set and then combines them. So this 4 5 6 7 8 and 9 and 10 11 12 from these sets are actually combined, and that is how it works. Let's also talk about some superset and disjoin methods. So let's actually see. Okay, so I actually am gonna remove this and we'll say print. Okay, first of all we have to make this set a little bit smaller. Yeah, that should be enough. So now I say print set A dot is a subset of set B. So if I just run this, it returns false. So it is returning false here. So what it basically means is set B should contain all the elements from set A. So here we have 1 2 3, but we don't have 4 and 5. So that is why it is actually getting false here. So if I just replace this with set B and set A here, this time we are getting true. If I just run this program, so if I just run the program here, I'm getting true here. So the reason is set B has all the elements from set A. So set B has 1 2 3 and set A also has that 1 2 3. So that is why we are getting true here. So now we are actually going to discuss about disjoint sets. So I actually have to say print set A or set A dot is disjoint set B. So if I run this program, we get false here. So uh, to for this to actually return true, both sets shouldn't have anything in common. So here they have 1 2 and 3 in common. So even if I just reverse this from set B and this to set A, it will actually return the same result because they still have this common element. So if they didn't have any common elements, this will actually return false. So this is the disjoin method. Now let's see how to actually copy a set. So I have a set here, so let's remove the set B here. So I have a set A with some elements inside it, so I can maybe say set CPY for set copy, and I'll set it to set A. And if I just print both of them, set A and set copy, and if I just CPY, and if I run this program, you can see both of them are actually the same. So we have actually created a copy here. But what if we actually change the values inside the set? This will actually be modified. We have seen before, because this is actually dependent on this thing, so this will naturally change too. So to actually make a real copy, we have to say set copy is equal to set A dot copy. So this will actually create a legitimate copy of this thing. So now even if we modify some values inside the set, nothing will be modified. For example, I'll actually say set copy dot add maybe 10, and if I run this program, you can see that only the second set has been modified and the first set or the original set still remains the same. So we also have another type of set called frozen sets. So such sets, or the frozen set, is actually immutable. In other words, we cannot change what is inside a frozen set. So let's just take an example. So we can declare a frozen set by saying maybe set A is equal to frozen set. This is actually a keyword to declare a frozen set, and inside this we can actually pass a list. So now if I print set A, okay, we can see that the type is actually frozen set. If I run this program again, we can see that the type is frozen set now. So if I try to add an item. If I say set a dot maybe add, okay, there is no such method to add it. So even if I run the program, I get an error saying that frozen set object has no attribute add. So we cannot literally add an item to a frozen set, so it is actually immutable. So we cannot actually remove. There is no such method for frozen sets, so we'll still get the same error. So this is all about sets. So this is everything about sets. See you in another tutorial. Bye.